All right, what we're going to talk about now is the reduction of a reducible representation. And this reducible representation is just one that I've made up, that I've made up in order to reduce. So I'm doing the cooking show thing where I pull out something ready to go. But, reducible representation could be something like when you followed all your vectors and you get this reducible representation for the vibrations of a molecule. It could have something to do with the molecular orbitals or whatever. But the main thing I want to show in this video is how to do reduction of a reducible representation. This is a simplified version of a character table here. So this is the TD character table. I've just taken off all the extra things that we have out here on the right-hand side and reprinted the simplified part of the TD character table. And I'm going to use the method that is in the Carter book on symmetry and group theory for how to do a quick to take a reducible representation and generate the irreducible representations. So what you need anytime you're going to do this is your character table, and then you're going to make a worksheet that's like this. So this part of the worksheet looks exactly like the character table, just redrawing the character table, and you need two other columns here. And this is using the formula that you've seen in the textbook. The formula is also given in the Carter table. This is just a quicker way and a more organized way to do it. So what am I going to do the reduction? 1 times 1 times my reducible representation here. 1 times 1 times 8 gives me 8 there. This one is a really good one to do, whatever the symmetric representation is first, because these are all going to be 1s. So it's simply going to be this times this, and this is always 1. So this times this value. So 8 times 1 times minus 1 gives me a minus 8 there. 3 times 1 times 4 gives me a 12 here. 6 times 1 times minus 2 gives me a minus 12. And this last one's going to be boring. So 6 times 1 times 0. Anything times 0 is 0, so that last one there is 0. And I can go ahead 8 minus 8, 12 minus 12 plus 0. This is going to be a 0. And then where did this 24 come from? 24 is 1 plus 8 plus 3 plus 6 plus 6 gives me 24. This is the order of the group. So 0 divided by 24 is still 0. All right, well, now here's where the real utility of this method comes in. So what we do is we're going to take this number and we're going to follow the pattern that we have up here, the pattern. So 1, 1, 2, 3, 3 is so the pattern then down here would be 8, 8, 16, 24, 24. Okay, the number, double the number, triple the number, triple the number. That's what I've done here. All right, then it gets tricky, of course, trickier as we go across. So 1 gave me minus 8. So this one is also going to give me minus 8. And the only real tricky part is when we run across negatives now. So negative 1. So the pattern up here was 1, 1, minus 1. So down here it's going to be negative 8, positive 8. Okay, same sign, sign changes. So negative, negative, positive. And then the zeros, of course, anything times 0 is 0. 1, 1, 2. So 12, 12, 24. This was 1 and 1, and now this is minus 1 and minus 1, so minus 12 would be the same pattern. For the S4 now, it's 1 minus 1, so the sign changes, so minus 12 becomes 12. 0, of course, just gives me 0. So here and here's the same sign, so minus 12, and then here and there is the same sign, positive 12 and positive 12. And of course, this one is all zeros. So anything times 0 gives me 0. I'm going to sum across now. So 8 minus 8 plus 12 plus 12. So 12 and 12 gives me 24. So this guy is in there one time. 16 and 8 is 24. 24 more gives me 48. And so this one is in there 2 times. 24 minus 12 is 0. And that gives me a 0. 24 minus 12 plus 12 24 minus 12 plus 12 gives me 24. So that one is in there one time. So whatever this reducible representation is all about, it is composed of an A2 plus 2 E's plus 1 T2. And one final check that we have on this is, so whatever number we have here in the reducible representation, this is the order of the reducible representation. So this is singly degenerate, so this guy gives us 1. Each of these E's give us 2, 2, and 2. And then the T, because it's triply degenerate, gives us 3. So 1, 2, 3, 4, 5, 6, 7, 8. So all that together gives us 8, which was the original order of the reducible representation. So that is our final check. What is awesome about this worksheet method is that if we have anything come out strange here, then something we've messed up along the line, because we will either get a 0 or we will get an integer here. Okay, if we get anything else, if I ended up at the end here and I summed across and I got 23 divided by 24, I got some strange fraction, then I've messed up either in how I was carrying this out or in building this reducible representation. Okay, well, that's what we'll talk about also, is how to get this reducible representation. This method is in the Carter book. If you have access to it, it has a great explanation. I'll also post a worksheet that goes through this specific example.